Hello and welcome to another session of the Kubernetes Fundamentals series only in CSharpCorner Live. My name is Rodrigo, and today we're going to go through all the different topics that I've showed you in the past in the first 8 sessions. So the goal here is to review all the different topics. And we're going to do that because the following week, we're going to see new things about containers and pods, such as resource limiting and some other things, okay? So let's get started for today. Remember that Kubernetes is this most popular container orchestrator that was built by Google, and it was released on 2015, okay? And it's open source, and it has a huge ecosystem of components and training materials, books, podcasts, videos, blah, blah, blah. A lot of things that we can get for understanding Kubernetes, okay? Its official website is kubernetes.io. So if you want to use Kubernetes, if you want to get a grasp of Kubernetes, you can do that in different ways. I think the most common one for developing applications and for testing purposes is just install a local Kubernetes cluster in your own machine, okay? And there are different applications that we can use for doing that precisely, such as Minikube, which is the application that I'm using in this series, okay? You can also use a managed Kubernetes option, such as Azure Kubernetes Service or Elastic Kubernetes Service, or Google Kubernetes Engine, and so on and so on. However, yes, of course, you need to have an account in those different cloud providers. Maybe you need a credit card for obtaining that account just for verification purposes. So I think this is not a very straightforward way to learn Kubernetes, okay? However, there are some options there. And finally, you can install your own on-premises Kubernetes in your own machines. Maybe you have a Raspberry Pi, maybe you have a bunch of servers that you can use in your own company, and you can install Kubernetes by using a tool named kubeadmin, which is an application that allows you to install Kubernetes in an on-premises environment. So this is cool. And actually, I happen to have Minikube, which is the application that I happen to love. And I have Minikube version, I guess is version 1.29 at the time of this recording. Okay, so you do the following thing. You execute Minikube, start, and then you specify the driver that you want to use, because with Minikube, you can use underneath it all VirtualBox, you can use Hyper-V, you can use Docker for Windows, you can use different providers where the different components of the cluster will be installed. I happen to have Hyper-V in this machine, so that's why I'm setting up the driver as Hyper-V, okay? And you can also specify the number of nodes that you want. For instance, I want, in this case, 3 nodes. So Minikube is going to deploy and create this cluster with 3 nodes, right? So this is great. I'm going to deploy this, and let's see what happens, okay? When you do that, because of the fact I selected Hyper-V, let me show you the Hyper-V manager. As you can see, this is running already a Minikube node. So actually, I think the installation is going to fail because I needed to delete the Minikube node beforehand. Anyways, I'm going to continue with the explanation, and I'm going to return once I get an error message there in Minikube, okay? So Minikube is great. You can go to minikube.6.kx.9io or something like that, or you can just search in Google for Minikube install, and you can download the installation executable, or you can use something like Chocolatey for installing Minikube, which I did. Actually, I love Chocolatey as the application manager for all my machines. That's why I use Chocolatey for installing Minikube, okay? So I already did this, Minikube start, and then I pass the driver that I want to use. Again, you can use VirtualBox or Docker or whatnot. You can see the different providers there in the documentation, okay? You can execute other commands such as Minikube dashboard. Once your cluster is ready, you can enable the Kubernetes dashboard by executing Minikube dashboard, and you can also delete the cluster by executing Minikube delete. Take into account that you need administrator permissions. In other words, you need elevated permissions for doing that, okay? So this is telling me that this VM is having trouble accessing blah, blah, blah. You know what? Let me just press Control-C. Let's delete the previous node that I had, Minikube delete. And this is going to remove the node that I showed you. And let's go back to Hyper-V Manager just to be sure that I don't have any more those virtual machines. So great. And now I can execute that command again, okay? Anyways, as you can see, this is just for bootstrapping Kubernetes in your own machine. You don't need to install Kubernetes by hand. So this is great for training purposes and learning purposes. Just be sure that Minikube is not meant to be used in a production environment, okay? It's just for learning purposes. And the other tool that you need that actually 99% of the time you're going to be using is kubectl, kubecontrol, or kubectl. It depends on the person that is pronouncing this particular command. I happen to pronounce it as kubectl. However, it's kubecontrol as well, or kubectl, okay? This is the command line interface tool for Kubernetes, and it allows you to communicate to the API component of the cluster. And actually, you can use kubectl for managing different clusters at the same time with the same kubectl. You just happen to move between contexts by executing some commands when you want to switch context, okay? And actually, this is the most important tool that you're going to use when managing Kubernetes in the command line. So you install kubectl. I think Minikube is not going to install it by itself. So you need to go and download kubectl from the Kubernetes website, or you can use Chocolatey again for installing that, okay? So when you do that, you will be able to execute kubectl commands for your cluster, okay? So actually, I'm deploying this cluster right now, and Minikube is going to configure my own kubectl installation, and it's going to pass the credentials and connection strings and so on for connecting to this particular cluster, okay? So I don't need to do anything else other than waiting for those nodes to be deployed. So this is great. Once you are connected to a Kubernetes cluster, then you can execute some kubectl commands, such as kubectl version to understand the version that you're running, kubectl options for listing all the global command line options that you have, and so on and so on, okay? If you want to display your cluster information, you can execute, for example, kubectl cluster-info, and this is going to display the detailed information about your cluster, okay? For instance, how many nodes you have, the IP addresses, and so on. So let's go back here. This is done. So if I go back to Hyper-V Manager, you can see that I have 3 nodes that are running right now, And this is because, again, I used Hyper-V as its underneath provider, okay? So I want to execute kubectl version just to show you what's going on here. So as you can see, I'm running this particular kubectl version, which is 1.26.1. Actually, this is the version. And it's telling me the version of Kubernetes. Actually, I don't think this is a very compelling way to understand the version of your Kubernetes cluster and your commands. Anyways, let's execute cluster info, okay? And this is running Kubernetes, as you can see in those different IP addresses, okay? So this is great. Let's go back here. I mentioned that you can change your context, and this is because you can control different clusters by using the same kubectl command. So you need to set the context and use the context by using kubectl config set context or use context and the name of the context that you want to use. So for instance, if I execute config get context, kubectl config get context, you can see that I have different contexts already configured in my own kubectl command. And this is because I have some clusters in Azure and some other things in other places, right? So I can change between contexts, so I can execute commands in those Kubernetes clusters, okay? So cool. You can also, instead of typing kubectl all the time, you can use aliases if your shell permits it, such as this example that I have here on the screen, that I'm using K as the alias for kubectl. You can do that, and this is for not typing all the time, okay? So cool. Let's talk about the Kubernetes architecture. So you might remember that there are many different components that the Kubernetes cluster has, and we can actually divide a Kubernetes cluster in two separate kind of nodes. The first one is the control plane, or master node, or control node, which is the place where all the different components are installed. I mean, all the different Kubernetes core components are deployed, okay? So this is the place where Kubernetes is running, all the brain of Kubernetes is running on the control plane, okay? So it's meant to be used as that. It's not meant to be used as a way of running your applications. So you can also have one or more nodes in the control plane, and this is very common when you want to achieve high availability, okay? You should have 3 to 5 replicated control planes if you want to have high availability, okay? What are those control plane components? The API server, key value data store, scheduler, the controller manager, and if you happen to be using managed Kubernetes option in the cloud, then you will be using the cloud controller manager as well. The API server, this is the API server. It's just like a regular web API that you can execute and you can invoke for doing things in your Kubernetes cluster. This is actually what kubectl is communicating to for doing things in my cluster, okay? This is just a REST API. Actually, you can execute by using, I don't know, curl or using Postman or whatnot. You can execute commands in that particular API server for managing your Kubernetes cluster. However, it's better to use something like the kubectl command or a user interface tool for managing your cluster instead of just executing those requests in your API. So the key value data store, this is the place where Kubernetes is gonna store everything related with the cluster, okay? The state, I mean, the current state of the cluster is being stored in etcd or etcd. It depends on the people that is pronouncing this, okay? This is a distributed, reliable key value store for the most critical data of a distributed system, okay? So it's very performant database, okay, for storing the cluster data. It's not a relational database, so it's not that you want to connect directly to etcd or something. Everything is managed by Kubernetes, okay? It's just writing the data in that particular store. The scheduler, this is the component that is watching for newly created resources, for instance, pods, and it assigns the work across all nodes, okay? So for instance, let's say that you want to deploy your application or web services or web, microservices or whatnot. So the scheduler is gonna schedule the deployment of those containers in a pod in the different nodes that you have in the cluster, okay? And the controller manager, it's there are many different controller managers actually running all the time, and their responsibility is to notice and respond when nodes and containers or endpoints go down. Actually, the controller manager is responsible for verifying that the desired state that you define, it's the same as the current state in the cluster, okay? So this is connected to the, maybe the deployment objects that you deploy for executing your own applications. And actually, as I mentioned before, there are many controller managers. Actually, there's one controller manager. However, there are many controllers, okay? And they track at least one Kubernetes resource type, okay? So one controller manager that is managing different controllers, okay? Cloud Controller Manager, this is the one that you use if you're using, say, Azure Kubernetes Service or Elastic Kubernetes Service. This is the component that Kubernetes uses for communicating to the cloud control plane. So, for instance, if you want to deploy, say, a service that is of type load balancer, and if you're using that in the cloud, then Kubernetes is going to use Cloud Controller Manager for deploying the load balancer in your account, in your cloud account, okay? So, for instance, this is not something that you use if you're executing Kubernetes locally. For instance, if I'm using Minikube, I don't have a Cloud Controller Manager running in this particular installation, okay? So the worker nodes, one or more nodes, this is actually the place where your application is they're going to be deployed, okay? And the worker nodes, they have different components as well, such as the node agent. The technical name of the node agent is kubelet, and this is an agent that is running all the time, and it's making sure that your containers are running in a pod and they are running correctly, okay? This is one of the components that all the workers have, and also the kube proxy, which is the network agent that it's also running all the time. And the proxy ensures that each pod has a unique IP address, and it manages all the things related to networking. And you can also have the container runtime in those workers, okay, in those worker nodes. Actually, most of the time, you're going to be using something like Containerd or Docker. Actually, it doesn't matter because those container runtimes are meant to be used by means of a container runtime interface. So in other words, this is similar to interfaces and concrete classes in object-oriented programming language, okay? So for instance, Kubernetes is gonna use the container runtime interface for communicating to the container runtime. That's why it doesn't matter if it's Docker or Containerd or any other, okay? Containerd, Docker Engine, Mirantis, or whatnot, okay? Cool. So you might remember that there are different fundamental resources that we can use and deploy in a Kubernetes environment. And I'm talking about the container. Of course, that's that's the place where your application is going to be living, or your microservice or whatnot. And we use a pod for deploying those containers. Okay, the pod is the smallest object that we deploy in a Kubernetes environment. Okay, makes sense? So the next one is the replica set, which allows your applications to replicate pods, okay? Not a single pod, but a set of pods that you specify as replicas. And the deployment, I think that's the most common one that we're going to use. The deployment, it deploys a replica set that happens to have a number of replicas of pods, okay? However, the deployment has the ability of rolling back and rolling forward those applications, okay? So that's why we can use the deployment instead of just using the replica sets or the pods directly, okay? A pod can have a container. Actually, most of the time, there's a one-to-one relationship between pods and containers. However, you can deploy more than one container in a single pod. This is useful for some design patterns, such as the, I don't know, maybe the sidecar pattern or some others that I'm going to describe right now, okay? However, before I define or describe those design patterns that are somewhere here in my presentation, such as the sidecar pattern, before I do that, let me explain and remember that we have two different approaches for managing and creating your objects in your cluster, okay? The first one is the imperative way. This is where you use an imperative command such as kubectl run, right? Or kubectl create, right? And on the other hand, the declarative way is when you use a manifest file that is most of the time a YAML file. It could be a JSON file as well. However, in Kubernetes, it's more common to use YAML files, okay? So we have two ways for doing this, imperative and declarative. I think declarative is the preferred way because those are YAML files that you can store in source control and you can see the history of changes, right? So those manifest files can represent the ultimate source of truth. And you can also use a hybrid approach. I mean, just execute your imperative commands and then obtain the YAML that you want to store in a file and so on, okay? So here's a couple of examples of the imperative approach. As you can see, the first one is running a pod and the other one is creating a namespace. So this is great. So I have my cluster here, right? Kubectl, get nodes. I have those nodes. So let's run kubectl run my nginx. This is the name of the pod, okay? And then the image, and I want to use this image name, okay? If you don't use a fully qualified name, then Kubernetes is gonna use Docker Hub as its main container registry, okay? That's why I don't need to use a fully qualified name for this nginx image. So if I do this, then I can see that this pod is running kubectl get pods nginx. As you can see, I mistyped this. That's why this pod is in the air image pool status, and this is because I had a typo, okay? So you can delete the pod, delete pod my nginx, right? And then try it again. Engine, is that right? Nginx, yes, I'm always confusing that. Again, I created the pod, and as you can see, this is being created right now. So it's pulling the image from Docker Hub, and eventually this pod will be running, okay? As you can see here on the screen. So this is just a small example of the imperative approach. And the other way, as I mentioned before, is just using manifest files. So you need to create those YAML files. And to be honest with you, YAML is quite straightforward to understand. Let's create session 9, and I'm gonna use Visual Studio Code because I installed a Kubernetes extension in my Visual Studio Code so I can create those YAML files in a very easy way, okay? Let's say that I want to create a pod. So I just type Kubernetes pod, okay? As you can see, this is like an IntelliSense kind of help that I'm obtaining here. So if I use this, you can see that I just need to change those placeholders, okay? For setting the name or the image name, which is nginx, right? And you can change other things such as the container port and so on. So for instance, if I create this, if I execute this YAML file, then I will have a new pod named my app. So let's do that. kubectl apply. This is the command that we use most of the time. And then my pod.yaml, and the pod that I describe in that YAML file will be created. I can verify that by executing, again, kubectl get pods, and eventually that new pod will be running, okay? So very easy stuff. And of course, as I mentioned before, you can use the hybrid approach if you want to, okay? This is just obtaining the YAML code and using that YAML code for creating your YAML files, okay? So this is great. Manifest files, as the one that I created, most of the time, they have 4 top level fields. Of course, it depends on the type of component or object that you want to create. So for instance, API version is the field that specifies the API version that you want to use for creating that particular object. So you can actually list all the different API versions that your cluster supports if you execute kubectl API versions, right? So as you can see, this cluster supports those different API versions, okay? So let's go back here. API version. Cool. The next one is kind. This is the place where you specify the kind of object that you want to create, such as pod, deployment, service, and so on. Metadata is for specifying, as its name implies, the metadata for your object, such as the name or the namespace, okay? So if I go back to Visual Studio Code, you can see that the metadata field had name and also labels, okay? And there are dozens of different metadata fields that you can use in those objects. So, and finally, spec, this is the place where you specify the information specific for your object, right? I think this is spec for specification, right? So this is the desired state that your object will have, okay? And Kubernetes is going to be sure that that desired state will be fulfilled, okay? So there are many fundamental resources and objects that we can deploy. Pod is the smallest one. However, we have dozens of different objects that we can create, such as replica set, deployments, services, namespaces, secrets, and config maps. Those are the different objects that we've seen in this particular series, okay? So let's talk about the pods. The pods are the smallest objects that we can create in Kubernetes, as I mentioned before, okay? And generally speaking, there's a one-on-one mapping between a pod and a container, okay? So this is the place that I wanted to show you, where I have the sidecar pattern. This is the design pattern that needs more than one container in the single pod. For instance, if you happen to use Dapper, which is a distributed applications framework, then you need Dapper running as a sidecar in the same pod, okay? And there are other design patterns that need more than one container in a single pod, such as init containers and the ambassador pattern, and also the adapter pattern. However, I wanted to mention Dapper because I think that's a great framework for creating distributed applications, such as microservices applications, okay? So pod, again, a pod can have more than one container, okay? But you don't actually scale an application just by adding more containers to a single pod. You don't do that, okay? You actually create more replicas in your cluster, okay? So that's what we do. Anyways, for creating pods, you can do that imperatively or declaratively, as I mentioned before, right? And the pods, they have a life cycle, okay? The life cycle is right here on the screen. So initially, a pod is pending. In other words, the pod has been accepted by the cluster. However, one or more of the containers aren't set up or ready to run, okay? And then the pod will be running, or it could be in the succeeded state if the pod happened to end, okay? And it could also be in a failed or unknown state. So there are a few commands that I showed you in this series, such as get pods, describe pod for obtaining all the detailed information about an object, not just pods. Kubectl describe and the name of the object that you want to describe. And then kubectl logs, kubectl exec for executing a command in a container that is running inside a pod, and kubectl delete as well. So for instance, if I go back here, say kubectl exec and the name of the pod, and then the name of the command that you want to execute. For instance, I want to execute env to list all the different environment variables that this particular container has, okay? Or you can also do that with an interactive session. So let's execute the shell. And as you can see, now I'm running inside the container. And I can show you that etc os release. And this is running Debian Linux 11. And yeah, I can just exit this by executing exit. And I'm returning to PowerShell. Okay. So the life cycle that I mentioned before, those different states are for pods. And those that I have here on the screen, those are for containers. Okay. So the container could be running or could be terminated or just waiting. Okay. Those are the container states. The previous ones were the pod states. So the replica set, when you execute I mean, when you deploy a deployment, you are creating a replica set as well. You can create a replica set by your own. However, I don't think that's the most useful way of doing that, because you can't roll back or roll out that replica set. Instead, you use a deployment. Anyways, a deployment creates a replica set. Okay. So the replica set is the object that ensures that a specified number of pods are running at any point. Okay. So you can actually create this. As you can see here on the screen, this is the manifest file for a replica set. And inside the spec field, we have the replicas key and then the value of 10. Okay. So this is the replica set spec. And underneath, we can have the template and then the template for the pod. Okay. So this is specifying the number of replicas, and then you can specify the template for the pod that this replica set will be using. So the deployment, I guess that's more real world. Instead of just creating replica sets manually, you use deployments. They enabled you to deploy and manage updates for pods in a cluster. Okay. And they can manage the life cycle of a pod. So let's go back here to the manifest. This is the manifest for the deployment. Okay, so you can see here, kind deployment. This is the deployment spec. Okay, this is telling Kubernetes, hey, I want to create 10 replicas, and then you specify the pod template. Okay, so actually at the end of the day, we're going to have 10 replicas of Redis. This is what this manifest is doing. Okay, so you can you create that object, you create the deployment object, and then you can describe your deployment. You can delete the deployment. You can list all the different deployments that you have. And you can also scale a deployment by using kubectl scale deployment and the name of the deployment. So let's create a deployment super rapidly. So let's do that by using, say, Visual Studio Code, my deployment.yaml, and I can type deployment and use this template, right? This snippet of code, and the image will be Nginx, and the container port is 80. I just want to get rid of the resources element, and that's it. API version, kind, metadata, and spec. This is the spec for the deployment. Okay, this is the place where I can say replicas and 10. Okay. And then here inside the template field, I can specify the template for the pod. Okay. So let's go back here. Kubectl get pods. Let's delete pod, my app, and let's also delete my Nginx. So I don't have any more pods. Kubectl apply my deployment. So this command created deployment, kubectl get deployments. So as you can see, 6 pods, 6 replicas already, and now 9 already, and finally 10 out of 10 already. So actually I can execute kubectl get all instead of just executing get pods, get deployments, get replica sets, right? So as you can see, I created 10 replicas of the same pod, and 1 deployment was created, and a replica set was created. Okay, this is important. The deployment created the replica set. It implies a replica set, in other words. Okay. So great, and I can actually kubectl get pods show you another command. Well, actually not the command, but the flag, O wide. This is for listing other columns, such as the IP address related to a particular pod, okay? So I can see that those different pods were deployed in the 3 nodes of the cluster. Actually, those 2 and this other one as well were deployed also in the control plane cluster. I'm sorry, in the control plane node. And this is because this is the way that Minikube is working. Most of the time, you're not going to deploy your applications in the control plane nodes. Anyways, the important thing here is that each pod has an IP address, okay? Cool. So I mentioned before rolling updates. So rolling updates for deploying your deployments, right? And you can also change some things about the deployment by using kubectl, such as if you want to set the image, or you can edit the manifest directly, you can do that, okay? Or you can change your manifest and then execute kubectl apply -f again, okay? So if you do that, then Kubernetes is gonna create a rolling update. In other words, it's going to gracefully deploy the new deployment, okay? So let's see if I can do this right. So I have the deployments, right? Get deploy. So kubectl, edit, deploy my app. If I do this here in Windows, this is gonna open the default text editor that is configured in my own operating system, okay? Which is, in this case, is Notepad. So I can say, I don't know, let's change the number of replicas from 10 to 20. If I save this, then Kubernetes is gonna gracefully deploy that deployment. So let's do this, get pods. So as you can see, I have many other different pods running all the time. Actually, it was very fast. However, the previous pods were deleted. Those previous pods were terminated, and the new pods were created. Well, actually, in this case, it just created 10 additional pods because I didn't change anything meaningful, okay? So actually, let's do that. Edit, deploy, blah, 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 20 replicas. Say that I want to change the image name. So Nginx, I don't know. Let's change to something else, such as Redis. Save. And as you can see, some of the new pods will be created and some others of the previous pods will be terminated, okay? So that's why I'm mentioning that Kubernetes does that gracefully. So, okay, this is not very compelling because not most of the time you're not going to edit your deployment directly, okay? So you might want to change the manifest file and then execute kubectl apply -f and then the name of the file that you changed. Anyways, rolling updates are for gracefully changing your deployments. Here's another command. It updates an image for a deployment. This is using set image instead of editing the manifest file directly. And you can also roll out your deployments by executing kubectl rollout status. I'm sorry, not the status. This is just for displaying the status, okay? But you can also roll out the deployment by executing kubectl rollout. Undo, actually, that's the command that I was trying to explain. So kubectl rollout undo, it rollouts, okay? It undoes a previous rollout. You can also list all the different rollouts that you had in the past if you execute rollout history. You can also restart the deployment, and you can also annotate the deployment, okay? annotations are used for setting additional data for your objects, okay? So then we talked about services. Let me see what time it's at. Okay, 10:16. Okay, cool. We have enough time. So pods are great. However, they have a unique IP address, and all the time pods are being created and terminated and moved around the nodes in the cluster. So those pods, they are not reliable to communicate to, okay? So that's not a good idea to reference a pod directly, right? Because the pod could change an IP address or it could be terminated without notice. So you can't rely on pre-assigned IP addresses. That's why we use services, okay? Services is another, a service is another kind of object that we can create in a Kubernetes cluster because it provides a stable IP and DNS name. That's actually what we do. If you want to communicate from a pod to another pod, then you use it by means of a service instead of direct pod-to-pod communication, okay? There are 4 types of services in Kubernetes. The first one is cluster IP. This is a private service that is living inside the cluster, and you can't get access to that particular service. On the other hand, node port is a service that you can communicate to externally. Okay, if you expose a node port service, then you can communicate to that service from your applications or from your machine. Okay. And finally, load balancer. This is one of the objects that use a cloud controller manager, because if you create a service that is of type load balancer, you should be running on the cloud, and then the cloud controller manager is going to deploy a load balancer object and resource in your cloud account, okay? And there's also the external name service. But actually, I think node port and load balancer in cluster IP, those 3 are the most common ones, okay? So services, they work like this. You have a service, instead of communicating directly to a pod, because the pod can change its IP address, right? Because it was terminated or something. So it's not a great idea to communicate directly to a pod. That's why we use a service that has a particular name in a stable IP address. So your application communicates to the service, and then the service communicates to the pods that are the backend pods for that particular service, regardless of the IP address of the pods, okay? So the service knows what are those backend pods that are going to be used when you execute something in the service, okay? So services are a great way for doing that, and Kubernetes implemented services in terms of a selector. So in other words, services are based on a selector, and selectors, they use labels for detecting what are the backend pods that your service is going to use, okay? So how in the world you create a service? You can do that by using kubectl, as you can see here. Kubectl run, blah, blah, blah. This is creating a pod, and then it's exposing the pod as a service, okay? Or you can just execute kubectl, create service, the name of the service, the type of the service, this is the name, this is the type of the service, and then the ports that you want to use. Or you can just use kubectl expose deployment for exposing an existing deployment. For instance, you can see here on the screen, kubectl expose deployment, the name of the deployment, and then specifying the port that you're exposing and the target port that is going to be used. for this service. Okay. So this is what's going on here. When you deploy a deployment, you have different pods that are being managed by the deployment. And also services, they also manage a group of pods, okay? A pool of backend pods. How in the world is this working? So the key thing to understand is that you're using selectors, okay? So for instance, this deployment that I just deployed is using this match label, okay? So in other words, this deployment is going to manage all the different pods that have the app label with the value of my app, okay? So that's why this deployment knows about those pods, okay? So if I create a service, as you can see, I have the selector field and then the label that I want to use. So in other words, if I deployed this service, then I will be able to manage the same pods as the deployment because it's the same selector, okay? So selectors, labels, and annotations, those are the key components to understand for deployments and services and some other objects that need a pool of backend objects, such as pods, okay? So let's go back here and let's jump right in to label selectors and annotations because I think I have enough time in 6 minutes to explain this. Labels, selectors, and annotations. So remember, labels are just key value pairs that are attached to objects. Actually, annotations are also key value pairs that are attached to objects. However, the difference is that with labels, you can use that for querying purposes. You can use labels for querying purposes, okay? That's the difference between labels and annotations, okay? And you can have different ways for specifying your labels. And as you can see here, I'm using env, blah, 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 tier, app, and so on. And then by using the selector, you can say, okay, I want this deployment to manage all the pods that have this particular set of labels, okay? And that's also true for services. Namespaces, they allow you to logically group resources, okay? Those are similar to namespaces in programming languages. This is for just grouping and having a well-structured set of objects and applications in your cluster, okay? Just be sure that your namespace should exist before assigning objects to it. So you need to create a namespace. You can do that imperatively or declaratively. So let's go right there. This is the way that you create a namespace by using the imperative way, by using kubectl create namespace, or just use a manifest file, okay? And then you use the namespace when creating objects, okay? For example, as you can see here, kubectl run nginx, it's using this image name, and then it's specifying that it's gonna be deployed in the namespace named team1, okay? And then you can use that flag for specifying in all your different commands that you want to filter out the objects that are inside a particular namespace, okay? So then we saw environment variables. Inside this spec, we have the containers element, and then you can the containers element, and inside the containers element, we can have the environment variables that we want to set for our containers. Okay, so this is the element that you want to set. env, and then the name of the environment variable, and then the value of that environment variable, right? Pretty easy stuff. So health checks, we saw health checks as a way of determining if the state of a container is healthy or not, right? They allow Kubernetes to monitor the health of your application and to determine what you want to do, right, in order to take action. So we have 3 different health checks, such as liveness, readiness, and startup. And those different health checks, they use different probing mechanisms, such as a command. In other words, you can execute a command when you want to do something about the health of the object, or you can execute an HTTP GET request or a TCP socket request. Okay, those are the different probing mechanisms. Config maps. This was the last session, I guess. Config maps, they allowed you to store configurations instead of just hard coding those configurations in your manifest files. However, with config maps, the data is not encrypted. Okay, this is for non-confidential decoupled configuration items. Okay, if you want to have more security, then you might use secrets. Secrets are similar to config maps, and they are better suited for storing sensitive data such as connection strings, API keys, passwords, or whatnot. Okay. However, out of the box, those values are not encrypted. Okay, they're just encoded in base 64 format. So if you want to enable encryption at rest, then you can enable some other things in your cluster, or you can use an external platform or application such as Azure Key Vault or HashiCorp Vault. Okay. So in other words, you need to enable some additional configurations in your cluster if you want to have encryption at rest, or if you happen to be using HashiCorp Vault in your on-premises environment, or maybe you are in the cloud, then you can use something like Azure Key Vault. Okay. And then we saw how to use config maps or secrets, and actually those are almost the same. As you can see here on the manifest that is at the right side of the screen, I'm using value from this environment variable, right? I'm injecting this environment variable, and the value comes from a secret, okay? Instead of just hard coding those values inside the manifest files. That wouldn't be a great idea, right? So that's why we use secrets all together in and alongside our applications. So we create secrets by executing create secret, kubectl create secret, or we can just use a manifest file. Very similar to the config maps and very similar to the other objects that we can create in Kubernetes. Awesome. So that's what I had for today. Okay. This was the learning checkpoint for this Kubernetes Fundamentals series. And thank you for your time. And I'll see you next time.